So let's define a variable as decimal and call it money amount and savings account. We've already discussed in previous tutorials that the decimal data type is an appropriate data type for storing money amounts because, in summary, it can store numeric values with a fractal part with high precision. Accuracy is obviously very important when it comes to financial calculations. We are not going to be doing any complex calculations, but let's use the decimal data type anyway. Let's initialize our money amount and savings account variable to a value of 400. Let's create another decimal defined variable and we'll call this cost of bicycle. Let's initialize its value to 1,000. So £1,000 will buy you this particular bicycle. So our top if statement will test whether we have enough money in our savings account to buy the bicycle. Notice we are using the greater than or equal to operator to compare the money amount and savings account variable's value to the cost of bicycle variable's value. If the test condition returns true, i.e. we have enough money in our savings account to buy the bicycle, let's output the text, I have enough money to buy the bicycle. And let's also include an else part to our if statement. So if the money, if indeed we have any money at all in our savings account is less than the cost of the bicycle we want to buy, the text, I do not have enough money to buy the bicycle, is outputted to the console screen. So we have £400 in our savings account and the bicycle costs £1,000, therefore code in the else part of the if statement is run and the text, I do not have enough money to buy the bicycle, is outputted to the screen. So let's force code in the true part of the if statement to run by changing the initialization of the money amount and savings account to an amount that is greater than the cost of the bicycle. Let's test our code. And the result is as expected, we now have enough money to buy the bicycle. So let's change the initialization of our money amount and savings account variable back to 400. Let's introduce a new variable defined as Boolean, and we'll name this variable CanGetLoan, and we'll initialize this variable's value to true. Let's use the OR operator, which is denoted by the double pipe characters, to include an evaluation of the value stored in the CanGetValue variable in our if statement. So now the if statement reads as, if there is enough money in our savings account or we can get a loan, this means we have enough money to buy the bicycle. Of course, in this scenario, we're assuming that the loan amount will be enough to cover the expense of the bicycle. So we can see the amount in our savings account is only 400, but we are able to get a loan which will cover the expense of the bicycle. Let's test our code. And the result is as expected, I have enough money to buy the bicycle. You could also use a single pipe character to denote the OR operator. The difference between a single pipe operator and a double pipe operator is as follows. The if statement is evaluated from left to right. With an OR operation between two expressions, only one of the expressions has to be true for the entire if statement to return true. So if the first expression from the left in our if statement, in this case evaluating the amount in our savings account is greater than or equal to the cost of the bicycle, is true, the expression to the right of this expression will not be evaluated because in order for the if condition to return true, only one of the expressions in the if statement needs to be true. In this case, the amount in our savings account is less than the cost of the bicycle, which means the first expression from the left is false, so the expression on the right of the double pipe operator will be evaluated. In this case, the CanGetLoan variable is true, so the expression on the right returns true. So the expression on the left is false and the expression on the right is true, so ultimately the if condition returns true because the Boolean expression false or true equals to true. So now the single pipe is also an OR operator, but will mean that even if the first expression on the left is true, that the expression on the right will still be evaluated. So let's force the expression on the left to be true by making the expression that reads, the amount of money in our savings account is greater than or equal to the cost of the bicycle, returns true. We can do this by simply changing the initialization of the money amount and savings account variable to a greater value than the value stored in the cost of bicycle variable. So let's test this. And it is the same result as when we used the double pipe symbol, but even though the first expression is true, the second expression is still evaluated. This is the difference between the single pipe and double pipe OR logical operators. In summary, the single pipe operator will force the expression to the right of it to be evaluated even if the expression on the left of it is true. If, however, we use the double pipe operator, if the expression on the left of the operator is true, the expression on the right does not get evaluated. With an OR logical operation, only one of the expressions needs to be true for the entire condition to be true. So now we are going to introduce a new variable which we'll define as decimal. This variable is named max loan amount. This variable name is self-explanatory. It stores a value denoting the maximum value we are allowed to borrow to purchase the bicycle. And let's initialize its value to 500. So we are going to use the double ampersand symbols to perform an additional logical AND operation to assess whether we can borrow enough money, which when combined with the money we already have in our savings account, will be enough to purchase the bicycle. So the if statement will now read, if the money in our savings account is greater than or equal to the cost of the bicycle, or we can get a loan, and the addition of the loan amount we receive to the money we have in our savings account is greater than or equal to the cost of the bicycle, we have enough money to buy the bicycle, else we do not have enough money to buy the bicycle. So with the double ampersand operator, both expressions to the left and right of this AND logical operator must be true in order for the logical AND operation to be true. If one of the expressions is false, the logical AND operation returns false. So if the can-get-loan variable's value is false, the logical operation of can-get-loan and max loan amount plus money amount in savings account is greater than or equal to the cost of the bicycle is false. If the can-get-loan amount variable's value is true, the evaluation of max loan amount plus money amount in savings account is greater than or equal to the cost of the bicycle will determine the return value of this logical AND operation. If the expression on either side of the AND operator is true, then the logical AND operation returns true. If one of the expressions is false, then the logical AND operation returns false. A single ampersand can also be used to denote an AND logical operation between two Boolean expressions. Unlike when the double ampersand is used, if the expression on the left of the AND operator is false, the expression on the right of the single ampersand symbol is still evaluated. So if the double ampersand character is used and the expression on the left of the AND operator is false, the expression on the right of the AND operator will not be evaluated because it is known at this point that the logical AND operation is false. When the single ampersand is applied in a logical AND operation and the expression on the left of the AND operator is false, the expression on the right is still evaluated. The logical operation will of course still return false. With an AND logical operation, expressions to the left and right of the operator must be true in order for the logical AND operation to be true. If one of the expressions is false, the AND logical operation is false. Just an added piece of information regarding the single ampersand and single pipe symbols. When the single pipe symbol is applied as an operator between two Boolean operands, this results in a logical operation like the one we have just discussed. When the single pipe operator is applied between two integer operands, this will result in a mathematical bitwise operation. Bitwise operations are beyond the scope of this tutorial, but this information shows an example of how the data types of the operands determine the context of the operation. The same idea applies with the single ampersand used in an operation. When applied between two Boolean operands, the operation is a logical AND operation, like the one we have covered in this tutorial. When applied between two integer operands, a bitwise mathematical operation occurs. So let's test the code, and the result is that we do not have enough money to buy the bicycle. The money in our savings account is $400. We can get a loan, but the maximum we can borrow, plus the amount in our savings account, is not enough to purchase the bicycle. So the code within our else part of the if statement is run. But if we increase the maximum amount we are allowed to borrow to $610, we have enough money to purchase the bicycle, and the if part of the if-else statement is run. So let's demonstrate this using the single ampersand operator. So we are now going to look at an example using else if within our if statement. So if we don't have enough money in our savings account, we next want to assess whether we have enough money with the help of a loan to purchase the bicycle. We can do this using an else if statement. So it is important to note how an else-if statement works. The parts of the if statement are processed in the order in which they are written from top to bottom. Code within if, else-if, and else parts of an if block are mutually exclusive, which means if more than one if or else-if condition is true, code within the first statement evaluated as true will be executed. Code within the other else-if conditions of the if block, even if true, will be ignored. So in our example, if we do not have enough money in our savings account, it doesn't matter that we also have enough money with the help of a loan to buy the bicycle. Both the if and else-if conditions are true, but the code within the if statement is processed because it appears above the else-if statement in the if block. Then, of course, if none of the if, else-if statements are true, the code within the else part of the if block will be run. Code within the other conditions of the if block will not be run. Let's run the code. And the result is as expected. So what if we want to check on our progress with regards to acquiring enough money to purchase the bicycle? So we can use another else-if condition to see if with the help of a loan, we have over half the money we need to purchase the bicycle. So the code within this else-if statement will run if we do not have enough in our savings account to buy the bicycle, we do not have enough money to buy the bicycle with the help of a loan, and the money in our savings account plus the loan amount is greater than half the cost of the bicycle. So let's test the code. And the result is as expected. So now we decide to include another else-if statement to see if with the help of a loan we have over 90% of the money to buy the bicycle. So note that we include this else-if statement above the else-if statement that assesses if we have over half the money needed to buy the bicycle. And logically you can see that it makes sense to evaluate if we have over 90% of the money to buy the bicycle before assessing whether we have over 50% of the money needed to buy the bicycle. If we have over 90% of the money, logically it is unnecessary to evaluate if we have over 50% of the money. Putting our else-if statement in the correct order will ensure that even if it is true that when we have over 90% of the money to buy the bicycle, this also means that we have over 50% of the money needed to buy the bicycle. That only code within the condition assessing whether we have over 90% of the money needed to buy the bicycle is executed. Code within the else-if statement assessing whether we have over 50% of the money is appropriately ignored. Right, let's perform some tests. The variable values will be altered before each test so that the appropriate code block within our if, else-if, else statements are run. So first we'll set the money amount in savings account to a value that exceeds the cost of the bicycle. So the cost of bicycle variable is set to a value of 1,000. Let's set the value of money amount in savings account variable to 1,010. So the code block in the if statement is run as expected. So let's change the value of money amount in savings account to 400 and the maximum loan amount to 610. This will ensure that the code in our first else if statement is run. Great. So let's ensure that we have over half of the money needed to buy the bicycle, but do not have over 90% of the money needed to buy the bicycle. Great. And let's alter the value of our variables so that these values indicate that we have over 90% of the money needed to purchase the bicycle. Excellent. And finally, let's force code in the else part of the if, else-if, else example to run by ensuring that none of the above if, else-if conditions are true. Great. This code can be downloaded from GitHub. Please see details of the appropriate GitHub repository below in the description. If you feel you have gained value from viewing this tutorial, please hit the thumbs up icon and please subscribe. If you have already subscribed, please hit the bell icon to be notified of future content, which will be coming soon. I look forward to reading your comments. Thank you.